So let's go to multiplication of radical expressions. So in multiplication, just like what we are doing um, with a normal multiplication of integers, we just multiply them, okay? Or for example, we have a fraction like 1/2 times 3/4. We just multiply 1 times 3, numerator to numerator, and denominator to denominator. But when you are dealing with um, with square roots or radical expressions like cube roots or square roots, we are going to multiply the coefficients and radicals separately, just like what we did in fraction forms, like numerator times numerator, denominator times denominator. So in radical expressions, we multiply coefficient to coefficient and radicals to radicals. For example, we have -2 root of 7 multiplied by 5 root of 2. So we multiply the coefficients -2 and 5. So -2 and 5, when we multiply it, it's -10. And then at this part, we can multiply the radicals by multiplying them directly. 7 times 2, and that's root of 14, right? So the answer is -10 square root of, oh, sorry, that's imaginary. Root of 14. So this is our answer. Okay, so second example, we have 3 square root of 8 multiplied by 6 square root of 3. So this is just simple. 3 times 6 is 18, and 8 times 3 is, okay, 24. But you can simplify this further by factoring 24 into 4 times 6. And this 4 inside the radical sign is a perfect square. So you can extract it, and this becomes 18 times 2 square root of 6. And the final answer will be 36 root of, okay, 36 root of 6. So when we are dealing with multiplication with radical expressions, we also consider that the indices or the index are also the same. It's not necessary na um, same yung nasa loob or yung ating radicand, but it is necessary na same yung ating indices. So for example, we have 4 square root of 5, and then 6 cube root of 4. So we can multiply these coefficients. We can multiply this. 4 times 6 is 24. However, we cannot multiply square root. Square root, we have an index of 2, but we are not just writing it for kasi ay na for some reason hindi na natin talaga siya sinusulat. So square root of 5 and cube root of 4 cannot be multiplied to each other directly, so we just copy them. 24 root of 5 cube root of 4, and this would be our final answer. Okay, next is we will be having the division. with radical expressions. In division of radical expressions, we usually leave no radical in the denominator. So, meaning we rationalize, okay, the denominator. Ibig sabihin, wala dapat na matitirang radical sign or radical expression sa ating denominator. So, for example, we have square root of 75 over square root of 5 or root of 75 divided by root of 5. We can also um, write this as in the same radical, inside the radical, 75 over 5. Okay, so this will be 5 times 3. Oh, I mean 25 times 3. 75 is equal to 25 times 3 divided by 5. And we know that 25 is 5 squared. So you have 5 squared divided by 5. So cancel this and it becomes 1. And 5 squared becomes 5. So we can say that it is square root of 5 times 3 over 1. And we know that square root of 1 is just 1. And the denominator 1 cannot we can try to not write it at all. So our final answer would be square root of 15. All right. So our second example is square root of 24 over square root of 25. When we try to um, put this in one radical sign, I mean 24 over 5, root of 24 over 5, we cannot factor this number 24 into something that would cancel 5 in the denominator. So, hindi natin kayang mag-factor ng 24. So, alam mo, i-factor natin yan. Sige. I mean, sige, 6 times 4. O, factor mo pa yan into 2 times 3 times 2 times 2. So, wala kang makakancel na 5. Hindi mo siya makakancel katulad ng nandito. So, hindi mo kayang gawing 1. However, we can rationalize. What I mean is that no radical expression should be left in the denominator. So, rationalizing the denominator comes with this process. So, root of 24 over root of 5, we multiply it by square root of 5 as well. Because this is just the identity, I mean the what they call this in the multiplication rule, the identity rule. Root of 5 over root of 5 is just 1, right? So root of 24 over root of 5 is still root of 24 over root of 5. However, this value of 1 is equivalent to root of 5 over root of 5. Hence, we try to multiply numerator to numerator, denominator to denominator. And what we are getting is a square root of 24 times 5 over the square root of 5 times 5 is 25. And we all know that 24 can be factored into 4 times 6 times 5. Okay, 4 times 6 is 24, then times 5. Over square root of 25 is 5. Yay! We do not have radical expression in the denominator anymore. So we just need to simplify this further into 2 square root of 30 over 5. So we extract 4 root of 4, then it becomes 2 outside, and then what remains inside the radical symbol is 6 times 5, which is equivalent to 30. So our final answer would be 2 square root of 30 over 5. Okay, so yeah, this these are equivalents. Okay, number 3, we have 5 over 4th root of 3. Okay, so we try to rationalize it by 5 root fourth by 5 over 4th root of 3, multiplying it to 4th root of 3 cube. Why do we need cube here inside? Because later you will see. Okay, 4th root of 3 cube. So these is also equivalent to 1, right? Okay. So we can do this 1 by multiplying numerator to numerator. 5 fourth root of 3 cube over fourth root of 3 times 3 cube. So meaning this is equivalent to 5 4 root of 3 cube is 27, right? And then this is equivalent to 3 to the fourth because there is a exponent of 1 here. So when multiplying with the same base, right? And then we just add the exponents. And 1 plus 3 is equal to 4. And then since this is in fourth root of 3 to the fourth, we just cancel the fourth root and the exponent 4. And we will be left with a value of 3 in the denominator. Hence, our final answer would be 5 fourth root of 27 over 3. So that's just the simplest, no? The simplest that we can do when dealing with rationalizing the denominator. However, there are such things na ma-encounter natin minsan na polynomials na. I mean, binomials yung nasa denominator and that requires um, more advanced knowledge. And I could teach it um, when we get on the lessons further. But for now, we go for integrating all what we've learned through this example.